Our next speaker will be Rupa Ganguly, who is an environmental engineer here at ISTC. She's worked here since September 2012. She's conducted research prior to this on energy at Lawrence Livermore Lab, and then she came to the University of Illinois to get her master's degree, which she received last year in environmental engineering. And today she'll discuss her work that she's doing here related to microalgae, aquaculture, and development of some plants in those areas. Or she also has some other topics she'll discuss too.
Good afternoon, everybody. Today I'm going to look at the economics of saline water management in inland mariculture. So this comes from a similar idea that Frederick was presenting, that if we were to have aquaculture in the coastal areas or near the land areas, we are looking at huge problems, environmental problems related to eutrophication. And I'm going to take a different approach, a different strategy to deal with the demand for aquaculture and seafood products, but at the same time find a sustainable and responsible way to manage the environmental impacts.
Oh, I see that.
Yeah, the same from the United Nations FAO report. And over here, just like Frederick mentioned, we have a huge demand for aquaculture products. Yes?
Can you speak up, please?
All right. Okay. We have a huge demand for aquaculture and seafood products, and since 1960s, the per capita consumption for seafood has grown from 7 kgs to about 17.5 kgs. So we can see that it is one of the fastest growing food production sectors. In addition, wild-caught fisheries, we can observe over here that since the mid-1980s, it has pretty much plateaued. So aquaculture has come in and taken this spot and provided the demand that the world has for seafood. Where do we stand? It's bad news first. We lag behind, and our annual trade deficit is $10.6 billion. So it is it is the number 3 top import that we have for this country. That comes after fuel and automobiles. Third is seafood products. Further, we have noticed that the aquaculture industry in USA has not picked up at a pace based on the demand that we have for seafood. However, the good news is that we are the world leaders in sustainable management of wild-caught fisheries. So we have the experience and the knowledge to transfer that in the aquaculture sector. Some of the things that Frederick mentioned, I will just skim over this. It is eutrophication, like we can see here, due to algal blooms. It is also further, the ecosystems on the coast are very fragile. One has to be find different trophic levels to manage the different types of contaminants that come in the system from culturing seafood. And further, there is transmission of diseases, there are fish escapes, there is different issues related to coastal culture of fish. Now, Frederick talked about coastal aquaculture, and I'm going to take a different position here, and I'm going to try and explain to you, if we were to take marine culture of aquatic animals and plants inland, maybe in Illinois, how would it look like? Our key issue over here would be, with respect to inland mariculture, would be how would the saline water be available to us? And once we have reared the fish, where would the saline solids and wastewater go? How would we dispose it? Hence, we go back in time and look at a 1968 report of the salinity of aquifer water. So this is groundwater that we are looking at, and in Illinois, as we go from north to south, our salinity increases, and in the southern parts of the state, it is even twice that of seawater. Hence we are closer to the ocean than we think, and we have the reserves for it. Further, we are an agricultural powerhouse. We have corn, soybean, and we could use that to supplement the fish meal that is used in aquaculture industry. Chicago is the 5th largest consumer of seafood in the country, and it imports 99% of its consumption. We can use that market if we were to grow it locally. And of course, over the last decade, there has been interest in the aquaculture industry. An inland mariculture system would be similar along the lines of a recirculating aquaculture system, because over there, much of the water that is used in the system is recirculated, is treated and then recirculated back to the fish tank. It could look similar to this system, where we have a space efficient and very heavy treatment based aquaculture going on. It could be a desert. It doesn't have to be agricultural land. It could even be, land that has been left behind after mining or other kind of operations that make it unsuitable. The key questions that I will address in my discussion now is, does the availability of salt water in Illinois confer a material advantage? Secondly, if we were to actually use this saline groundwater, what would be the cost associated with treatment and disposal of the saline wastewater once we have generated it? This is a very basic schematic of a recirculating aquaculture system. Here is our fish tank. We bring in synthetic saline water because it's inland, and then we further add fish meal. Our fish grow happily. Then we have the particulates and solids from the system that go out as waste. The fish they utilize about 10 to 50% of the nitrogen and the phosphorus in the fish meal. The rest of it goes out as ammonia and is toxic to the fish. Hence, it is treated by a nitrifying biofilter. The nitrifying filter converts the toxic ammonia into nitrates, but nitrates build up over time, and we have to supplement 10%, typically 10% of the system volume in order to maintain the water quality as per the requirements of the fish. So what would be our inputs? We would have about 10% water input, we would have a generation of solids, and then we will have about 10% of wastewater getting generated from an efficient recirculating aquaculture system. This is an improved system. The previous one we looked at was a baseline system where the quality of the water was being maintained by heavy nitrification, and then at typically about 10% of the water was being exchanged. In an improved system, which is a denitrification based system, our work has indicated that we could use a large amount of the wastewater and essentially denitrify it using the waste solids that are present in the fish tank. And there is a lot of work that supports that, because as high as 99.5% of the water in the fish tank system could be recirculated after being denitrified. The second advantage is the waste solids in the fish tank will actually act as the carbon source for the denitrifying bacteria, and hence our solid waste volumes would also decrease. We further went on to the next step, where we tried to design an aquaculture system based on 3 different management scenarios. Firstly, we looked at a baseline system, which essentially is this system where you have synthetic saline wastewater and you have to manage the disposal of your wastewater that comes from your nitrification step, and then you have solids that also need to be disposed. So there is the baseline system, and the second the second management scenario that we considered was saline groundwater. This is utilizing the aquifer water that we have available in Illinois. So what would be the reduction in cost if we were to use saline groundwater instead of synthetic water? And the final is the denitrification based RAS system, where we have actually used saline groundwater, and the next step we have tried to understand is how the denitrification system can actually reduce the water disposal, the wastewater disposal. We can see here for a system that produced 100,000 pounds of fish, growing juvenile fish from 50 grams to about a market size of 750 grams, the water consumption, the water cost is in the baseline system is the primary expense. And then you also have your disposal cost from solids and wastewater. If we were to substitute the wastewater in the the synthetic salt water in the baseline with saline groundwater, which is underutilized at this point, then we would reduce our cost by a large extent. About 75% of the operating cost would be reduced. Further, if we were to use the solids from the fish tank as the denitrifying carbon source for the bacteria, we would further drop it down, and the actual saline water requirement would be less than 1% of the system volume. This essentially brings us to a point where we can see that by using our natural resource of saline groundwater and by using the denitrifying biofilters that use solid waste, we can have a 98% cost avoidance. Coming back to the questions we asked before, does the availability of salt water give us a material advantage? Yes, it does. And what are the costs associated with the treatment and disposal? So here we notice that it was a 98% cost avoidance from using the natural resources and being environmentally sustainable with the solids and the wastewater. Could this work be translated to other inland states? Here is a USGS report from 1965 that shows other inland states also have saline water resources within a few hundred feet from the surface, and this again could translate beyond Illinois and be useful in other states. I would like to acknowledge the people I worked with. My supervisor, Dr. Kishore Rajagopalan, was of immense help and support, and Dr. Brian Small from SIU Carbondale and Dr. Pamina Quadrani from Purdue University did some of the socio-economic analysis in this study, and I'll be happy to take any questions that you have.
Thank you.
So what fish are you looking at using?
We looked at rearing hybrid striped bass. So we had two cases. In one case we used synthetic salt water for rearing them, and in the other one we used simulated aquifer water which is very similar to the saline groundwater that we have. So in both cases, these were like 6-month experiments, and it was found that the fish in both systems grew equally well, and they reached market size, and because the water quality was being controlled, their feeding levels increased, and over time they had better growth rate than expected.
Have you looked at shrimp too?
No, we haven't looked at shrimp, but with hybrid striped bass, it is a species that has a huge salt tolerance. It can live from bright ocean water down to like 1%, and in different stages of its life, it can even live in fresh water. And there was an observation that the fish, perhaps the saline groundwater will require some pre-treatment depending on the species you choose and their water quality requirements.
Yeah, there are a couple other species in Illinois that do well in brackish water, and I can talk to you about some of those.
Okay. Any other questions?
Okay, thank you again, Rupa.